Hello everyone! Today I'm going to introduce you the 3D spatial analysis method and application. First, let me introduce you what is a 3D spatial analysis. The spatial analysis is a spatial data based on the location and the shape of the geographic objects. The powerful spatial analysis capability is the main feature of the GIS. It is used in all aspects of our lives. Like in this picture, we can analyze whether the height of the building exceeds the prescribed skyline, or can we observe a certain feature in a certain location? This problem can be solved by the 3D spatial analysis, and the display of the spatial analysis in a true 3D scene can more intuitively express the effect of the analysis. So, what are the methods and the application for the 3D spatial analysis, and what fields can it be applied to? Let's take a look at it. There are many 3D spatial analysis methods such as the flood analysis, skyline analysis, and visibility analysis. And today, I will focus on this method for you guys. Respectively is visibility analysis, flood analysis, sunshine analysis, slope and aspect analysis, 3D spatial query, and the lofting analysis. Okay, so let's look at our first analysis, visibility analysis. The visibility analysis needs to specify the observation point and the observed point. And according to the position of the obstacle, and calculates the visibility between the observation point and the observed point, and determine the visibility along the line of sight between this point. For example, if we go to a restaurant on the 19th floor for this building and want to see the whole view of the park, and then we can use this method to analyze. And what we need to pay attention to is the one-to-many relationships between the observation point and the observed point. The maximum angle of the multiple sight line in the 3D visibility analysis should not be greater than the 120 degrees. So this is a question in our quiz. The maximum angle should not be greater than the 120 degrees, and the sight line exceeding this value are gray. And now let's do our first exercise to look at what is the visibility analysis. And now let's open our supermap at desktop. Okay, first let's open the data that I have sent to you. It's in the 3D spatial analysis method, in the 3D spatial analysis method and the application, and it's in the our data. We could add the cbd.udb and the dem 25w.udb to our supermap at desktop. Okay, and so in this analysis, in the visibility analysis, we should use the CBD dataset. And let's add the CBD to our map window. Select the dataset in the CBD and right-click and add it to the new spherical scene. Add this data to the new spherical scene. And then right-click it and select the zoom to layer. Select the zoom to layer. And we could see that is the CBD in the Beijing. And then let's select the building, like in this building. There have the restaurant in this building at the 29th floor, and the position is in there. So if we are in this restaurant and we want to look at the whole park, the whole view of the park, and then so let's use the visibility analysis to analyze whether we could look this whole view of the park. So where is the visibility analysis? If everybody opened this 3D scene, open this dataset, and I will go through. The visibility analysis is in the tab of the 3D analysis. In the tab of the 3D analysis, there have the visibility analysis. So we could see there are so many analyses in this tab. Okay, but we just open the 3D scene and this tab will appear. And then let's one-click the visibility analysis, and it will appear the 3D spatial analysis flow window. And we could see if our mouse is in the map window, it will appear that please draw the viewpoint and perform the visibility analysis. So first, we could draw an observation point at this restaurant in this tall building. So we could click the point, and then we could draw the point being observed and perform the visibility analysis. And let's determine could we view the whole view of the park. We could see the green line is that we could see this view. And if we click there, okay, if we want to look at this point, there have the red line. So this red line that we could not look at this point. And could we see this pavilion? And could we see the whole view of this park? Okay, that is visibility analysis. we should determine the observation point and observed point, and determine if this line of the sight that we could see. So that is visibility analysis. If you wanted to see some points that you want to see, and you could use this analysis. Okay, and then we could right click and to finish this analysis. And let's come back to our PowerPoint. And this is our visibility analysis. And then let's review our visibility analysis. So first, the position is in the tab of the 3D analysis, and it's in click this visibility analysis button, and it will appear the 3D spatial analysis windows. And we could click this button, click this add button, and select the observation point and observed point. And then you could set this x, y, z coordinate of the observation point or the observed point, and modify the position of this point. Okay, so visibility analysis can be widely used to determine the visibility of the buildings, monitoring coverage, and the communication signal coverage, and or the military fair coverage, or the military installations, and many other aspects. So if you wanted to determine whether the building is blocking the line of the set, you could use this visibility analysis. Okay, and next, let me introduce you the floating analysis. The floating analysis dynamically simulates the floating process of the certain area from the minimum elevation to the maximum elevation, and based on the specific maximum and minimum elevation values and the floating speed. And the floating analysis is suitable for the terrain and the oblique photography data. So let's look at our second exercise. In this exercise, let's determine whether the Beijing area will be flooded. Okay, so for the data, we use the DEM25W.UDB. And in this analysis, we hope you guys quickly handle the basic operations related to the floating analysis. Okay, then let's open the supermap at desktop. Okay, and then we are going to click this window, close this window, and don't save it. And in this exercise, we will use the DEM25W, and we could use the DEM data, that is Beijing terrain data, and right click it and add to the new spherical scene. Add it to the new spherical scene, and then let's double click this, add as an image and add it as a terrain. And click OK. We have to introduce you that the difference of the image data and the terrain data. So if you are interested to it or you have some question of this, you could see our second course. Okay, and then it's successfully complete to add the DEM in our spherical scene. And then we could see that the 3D spatial analysis is still opened, and then we could find the floating analysis in this window, and then we could see this add button. Click this add button, and then we could draw a polygon to proceed the floating analysis. Okay, and let's draw a polygon. Draw the polygon and right click to finish it. We could see that is the process of the floating. So we could see the floating altitude in this window, and the mean visibility altitude and the max visible altitude. So we could see the floating analysis is dynamically simulated the process of the floating. So we could click another polygon to look at it. We could see this total time is 10, and let's click another polygon and right click. We could see that's another polygon area that the flood process of the flood. Okay, we could see we can use this analysis to determine the time and the process of the flooding. So that is the flooding analysis. And let's come back to our PowerPoint. That is our flooding analysis. And then let's review the flooding analysis. We could click this add button to draw the flooding area, and we could use this box to display and set the elevation value by the current water level. And the flooding analysis is in the 3D analysis tab, and in the third button is the flooding analysis. So according to the flooding analysis, to the rising speed of the flood in a certain area, and the inundation process when the flood rises to the specific elevation is simulated, which provides a certain reference for the flood control and disaster relief. And the results of the flooding analysis can provide the basis for the site selection of the water conservancy project or the construction sites in the river area. So it could use in this site selection and the flood control and disaster relief and the water conservancy project construction. Okay, next let's look at the shadow analysis. The shadow analysis can obtain the lighting information in the designated area according to the specified maximum and minimum height, and sampling distance and sampling frequency. And the lighting value represents the percentage of the time between the start time and the end time of the sunshine time at that place. And the analysis results can be exported as the 3D point data. Okay, then let's do our third exercise. Our third exercise is simulated of you buying a house. You want to query the lighting information of the certain community from the 6 a.m. to the 6 p.m. on a certain day in the winter, and determine the floor with the most abundant lighting so as to provide a certain reference for your house purchase selection. In this exercise, we are going to use the cbd.udb, and we want to quickly handle the relevant basic operations of the shadow analysis. And then let's open our supermap at desktop. And then we will use the CBD data source. And select this data site and add it to the new spherical scene. And right-click one data site, zoom it to the layer, and I invisible this skyline and the sunlight. Okay, and let's select a building. I'm going to select this building and find the shadow analysis. Okay, this shadow analysis, you could click this 3D analysis tab and find the shadow analysis. And then let's click the add button and draw a polygon to proceed the sunshine analysis. And let's draw a polygon with our mouse, with our left click and right click to finish it. And there will appear the result of the sunshine analysis. We could see the right point represents the high value of the sunshine, and the blue or the green point represents the low value of the sunshine. And we could modify the time in this window, and click the simple frequency, modify the sampling frequency as there. Okay, and that is our sunshine analysis. Okay, and that is our shadow analysis. And then let's review this analysis. The position of the shadow analysis is in the tab of the 3D analysis, and we could see the shadow analysis button is in there. And when we click this button, it will appear the 3D spatial analysis, and we could click this add button to draw the shadow analysis range, and use this box to modify the sampling distance and the minimum height and the maximum height, or the time and or something. So we could pay attention to this sampling distance. It will output the frequency of sampling points within the specific plane and height range. So if we modify these parameters, and we could click this perform the analysis to modify the result. And this function is widely used in the civil engineering, urban planning, and landscape analysis, and other fields, such as in the urban planning, during the site selection, and the spatial analysis function can output a suitability model as an important reference. Okay, next, I'm going to introduce you the slope and aspect analysis. And the slope and aspect analysis, it's divided the slope and aspect. So the slope is the angle formed by the tangent plane at a certain point on the ground surface and the horizontal plane. And the larger the slope value, and the steeper the terrain, and the smaller the slope value, the flatter the terrain. So the direction of the slope change is called the aspect, which refers to the downslope direction with the largest rate of the change from each pixel to the direction of its neighborhood pixel, and represents the measurement of the slope direction change at a certain position on the ground surface. So the 3D slope aspect analysis is used to calculate the slope value of each pixel in the raster dataset and the orientation of the slope surface of the pixel. So the range of the analysis result expressed in degrees for the slope is from 0 to 19, and the range of the slope calculation is from the 0 to 360. So maybe let's do the exercise, and you could fill these degrees. For our exercise, we are gonna to analyzing the slope and aspect from the Beijing-Tianjin area, and we are going to use the DEM25W dataset, and we help you to quickly master the relevant basic operation of the slope and aspect analysis. And then let's open our super map at desktop. And let's close this window and add the DEM to the new spherical scene. Right-click the DEM and add it to the new spherical scene. So that add this terrain data as an image and add this as a terrain, and click OK. And right-click and zoom to the layer. You could see that is raster data, terrain data. We could see it has the undulation of the terrain. So before we do the slope and aspect analysis, we must to generate the catch, the terrain catch of the DEM. So let's close this windows. No, close it and don't save it. And right-click this DEM and there has generates a catch. The operation of the generates a catch is in our second class, and I have introduced to you guys. Click this generate catch, and it will open the generate scene catch, and let's select the path of the catch. Select the path and select this storage tab as the origin, and we should click this bring normal. And why I want to show you how to generate the catch is because I want to remember that you must check this bring normal. So the terrain catch for the slope and aspect analysis should be checked this with normal when generate the catch. And then let's click OK to generate the terrain catch. Wait for the minute. Okay, it's successfully complete the generate the catch, and let's find the scene and right click and to create the new spherical scene, and then let's select the terrain layers and add the terrain catch layers, and let's find that we generate the catch. It's a .sct. The file extent name is a .sct. Okay, and let's right click it and zoom it to the layer. Okay, and we could see it's don't have the color, and we could set the color with the show normal, and select the properties of show this aspect, or we also can use this analysis as we could find the 3D analysis and find the slope and aspect analysis, and click add button to add the area to draw a polygon to proceed the slope analysis. And let's draw a polygon and right click, and let's look at its flow, and we could click the slope and aspect and click the flow. That will be appear the arrow that express the aspect, the direction of the aspect. Okay, that is slope and aspect analysis. And we could also, as a result, we could also set the display mode, like the transparency or the color table, and another related parameters. Okay, and let's come back to our PowerPoint. This is our slope and aspect analysis. And let's review the slope and aspect analysis. First, the position is in the tab of the 3D analysis, and it's the first button. of the slope and aspect analysis. And when it appears windows, and we could click this add button to draw the analysis range. And we could cite the parameters in this box, include the display mode, the transparency, and the color table. So this chat box also flow that could appear that the arrows in the analysis area having a falling effect. And slope and aspect analysis has a very wide range of the applications in the geological disaster and the land surveys and elevation of the cultivated land quality and the measurement of the land use. Okay, and let's look at our next analysis, the 3D query. The 3D spatial query is to query all the model objects that have the query conditions with the specified query objects in the query layer through the spatial position relationship between the objects. And currently supports the spatial query of the point and the model objects. So if you have the points dataset and the model dataset, you could use this 3D spatial query to analyze your data. And then let's look at our, let's do our fifth exercise. And there have the situation of and the city road needs to be widened and reconstructed. And according to the proposed road model and building model data provided, and the buildings need to be demolished or inquired, and the demolition plan is prepared. So we could select we should according to the road and select the building that should be demolished. And we will use the CBD dataset. And through this exercise, and you will handle the relevant basic operations of the 3D courseware query, 3D spatial query analysis, and the understanding of the related operations. And then let's open our supermap at desktop. So first, let's close this window that we have done, and in this exercise we could use we are going to use CBD data source, and let's select the CBD, the data set of the CBD, and add this to the new spherical scene. Okay, and let's right click it and zoom it to the layer, and invisibility the data set that we don't use. Invisible this data set, and we could find this road. So in our exercise, we wanted to construct a road, and we wanted to determine what building is and according to this road, and to query the buildings that need to be demolished. Okay, so for the 3D Spatial Query, and it's not in the 3D Analysis, and it's in the Spatial Analysis tab. Let's find the Spatial Analysis tab, and the 3D Spatial Query is in the Spatial Query tab button. Okay, so first we need to select our road. Let's click the tab of the scene and switch our mouse to the select, and let's select our road. Okay, that is be selected, and let's click the Spatial Analysis tab. Click the Spatial Analysis tab and find the Spatial Query. Find the 3D Spatial Query. Okay, and we could see that there have the searching layer is our road 1. That is the layer with the selected query. And then let's select the set query the conditions. So first let's select the queries layer. Let's select the building and select the spatial query condition. We could select the include the contain or identity, intersect. So in our exercise, we wanted to query the buildings that should be demolished. So we should select the intersect. And then we can save our results and click the query. Okay, and we could see the buildings that we queried is a highlight in our scene, and because our buildings ID of this are the same, so it's query the entire building. So if for your project you could set this building of the difference ID. Okay, so now we have selected our buildings that need to be demolished. Okay, that is our 3D the spatial query analysis. We could find it in the tab of the spatial analysis in the 3D spatial query. Okay, so don't remember you could select the road before your query. Okay, and let's come back to our PowerPoint. Okay, and that is our 3D spatial query. And the 3D spatial query is in the tab of the spatial analysis, and it's we click the spatial query button and we could find the 3D spatial query. So that is a window of the 3D spatial query, and for the searching layer we could select the query object before we query, and then we could set the query conditions, including the spatial query conditions and the attribute query conditions. So in our exercise, we just set the spatial query conditions. And for the spatial query operators, it includes separate, overlap, intersect, or and so on. So the search object and the search layer must be the same coordinate system. That is, we should pay attention to, and we could save our result, and then click the query button. Okay, and then okay, and that is a 3D spatial query. It could apply in many industries. Okay, and next let's look at the floating analysis. So what is the lofting analysis? The lofting analysis realizes the conversion of the 3D line into a closed model, in which the section style of the model is based on the drawn section view and the self-identified material settings. And the stacked objects can be the selected 3D line or all the 3D lines in the entire layer. So at this time, you may be asked, what can you do with this lofting analysis? And here are some examples. You could use it for the tunnel digging and use it for the construction of the pipelines. Okay, and then let's do our last exercise. Create the tunnel dig and dig a hole in the terrain based on the tunnel. And we should use the DEM25W data source. And through this analysis, we could quickly handle the operations of the 3D lofting analysis and the Boolean erase operation. Okay, and we could see that is the result of the exercise. We will use the tunnel to tunnel a hole, to dig a hole of the terrain data. So let's open our desktop. And then let's close the window that we have finished. Okay, and then in this exercise, we are going to use the DEM25W data source and the DEM data site, the DEM4SICHUAN data site. And so first, for our lofting analysis, we will use the terrain cache to do this analysis. So we should generate the terrain cache of this DEM Sichuan. So let's right-click the DEM Sichuan and select the generate cache. Select the generate cache. And then let's select the cache path in this data folder and select the bring normal to generate the terrain cache with the normal, and click OK. And with OK, it's successfully completed to generate the terrain cache. And let's create a new spherical scene. And select the terrain layers and right-click to add the terrain cache layer. Right-click the terrain layers and add the terrain cache layer. And let's select the terrain cache that we have generated. It's a DEM SICHUAN, and click this. And right-click it zoom it to the layer, and let's click our middle mouse to look at our DEM. And then in order to conveniently see this terrain data, let's add this Sichuan to our current scene. Add this raster data to our current scene. Right click it and add to the current scene, and add it as a message. Add this as a message and click OK. And let's zoom it to a layer. Okay, and then we could create the tunnel as our and then we could create the new data set. Create the new data set and create the 3D line as our tunnel. Create the 3D line and let's modify its name, because we have a tunnel, and we could click this tunnel 1 and create the tunnel and drag it to our scene, our windows, to our map windows, and click this edit button. Click this edit button, or we could right click it and click the editable. Click this edit button to make it to be edited, and it will appear the tag of the drawing, and we could click this polygon to draw click this polyline and to draw a line in our terrain. Okay, and we could select this area. We could dig a tunnel in this area and right click to finish our drawing. Okay, and this is our tunnel as a 3D polyline, and then let's do the lofting analysis. Okay, and then let's click the 3D Designer tab and find the modeling by rule. And in the modeling group, we could find the lofting analysis. Let's click this lofting analysis. The lofting analysis could realize the conversion of the 3D line into a close precision model. So we could modify its materials and to design its shape. So for the object layer, we could select the tunnel 1 that I have created it, and if we have many objects, we could select the selected objects, and if we just have the one object, we could select both of the all objects and the selected objects. And then let's design its parameter settings. Because it will convert the closed prediction model. So we must to draw a region. So let's select the polygon. Select the polygon to draw the region, and let's draw the point of our polygon. Okay, and we could draw the polygon like the tunnel. I just draw the very accidentally, and it's look like the circle, the half a circle, and let's click OK. Select the polygon and draw the shape of the tunnel and click OK. And then we could select it smooth, and select it the chamfer, and select the materials. If you have the texture, you could set its materials or set its color. So we could set its color as black, and it will more highlight. And then let's click OK, and click OK to do the lofting analysis. Okay, and we could see the lofting analysis is to convert our 3D line to the closed model. Okay, and we can invisible our terrain layers and to look like our tunnel. Okay, and then so then how to interact our tunnel and the terrain data and the tunnel dig of our terrain. So let's right click our DM and right click our tunnel 1 and zoom it to a layer. And so for this step we should do the Boolean operation. We are going to do the Boolean operation. It's in the tab of the 3D design and in the group of the TIN terrain operation. Now let's select the Boolean operation, and then add the layer as our builder result. So before we do the Boolean operation, we could determine that our model is the same as the projection of our terrain. So let's right click our builder result and click properties, and let's determine its coordinates. So it could be and our model data should be the geographic coordinate system. So we should do the projection transformation, and let's select the projection transformation and to target its coordinate system. Because our DM, our terrain data is China 2000, so our model data should be set the China 2000. And let's click convert. It will convert the new model data. And then let's do the Boolean operation. Click this Boolean operation and add So before that, we should drag it to our map window and click the bottom operation as builder result 1. Builder result 1, that model is that we we convert its projection, convert its coordinate system. And then let's click OK. And for the spatial relations, we will select the erase. It will calculate the terminal and the terrain data's intersect. So we could click check, and it says it will satisfy the condition of the bottom operation. And then let's click OK, and to wait a minute, it will generate it. And let's look at it's successfully completed. And then let's invisible our build data and invisible our the DEM, the image data, and let's find that digital. That's our dig. Okay, and let's find it. It's ignored. And let's open our terminal. Okay, maybe it's not obvious. So let's modify its color. Click this show no more, and right click our terrain cache, select the properties, select the slope and aspect properties, and to select it to the green. And we could see that is the terminal that we have created in the terrain data. It's in there, so we could see that is that is our terminal, and it is the terminal in the terrain that we have use Lofting Analysis and the Boolean operation to create it. Okay, and that is our Lofting Analysis. We could see in there, right? You could see that is the hole in the terrain that we have created. Okay, that is a little exercise of the Lofting Analysis. And let's come back our PowerPoint. So this is the Lofting Analysis. It's our exercise 6. And then let's review our Lofting Analysis. So first, we are gonna to create the 3D line as our terminal, and then let's to do the Lofting Analysis to convert our 3D line to the closed model, and the lofting is in the 3D designer and in the modeling by rule, and in the group of the modeling, we could click this lofting button and it will appear this windows of the Lofting Analysis. And in this window, we could select its object layer as a thumbnail. And if we have a lot of thumbnail, we could select it one object or select it all objects. Or if we just have the one thumbnail, one 3D lines, we could select both. And then we are gonna to set its shape to draw a polygon to appear our thumbnail's shape. And pay attention to there, we must to draw a polygon. It must be a closed model. Okay, and then we could set its smooth and the chamfer and its materials. If you have the texture, you could set its materials or modify its color or change its color. Okay, that's our lofting analysis. And then we are successfully to create the closed model as our thumbnail. And then we should do the bottom operation of our terrain data and the thumbnail and the closed model which is a thumbnail. Okay, for the bottom operation, it's in the 3D Designer and in the TIN Terrain Operations group, and we could select this button, the bottom operation button, and it will appear that window. And to select our builder model, so before that we should determine our model is a geographic coordinate system, and it must be the same as the terrain data. So we change its coordinate system as the China 2000, and to do the erase operation, the intersect operation. And then it will modify our terrain data, and it will appear the thumbnail. Okay, so we should pay attention to this confirm the model data for the bottom operation with terrain and deleting or select button. So thumbnail digging selects the erase bottom operation. Okay, so for our lofting analysis, we could apply it in the thumbnail digging. And if we wanted to construction of the pipelines, then we could also use this lofting to create the 3D lines and construct it as pipelines underground. Okay, that's our last lofting analysis. So today's class is finished. Thank you. And you could subscribe our YouTube account.